In this question from the chapter Similar Triangle, it says we are given a figure and PA, QB and RC are perpendicular. So we have this line, and this line given perpendicular to AC. Further, what we are given, we have to prove 1 over x. 1 over x plus 1 over z is equal to 1 over y. So we are going to use the concept that proving two triangles similar and writing their sides as proportional. So in the first case, I'll be using taking one triangle as this, and the other triangle I'll take as this. Right? We'll be writing these two triangles similar, or maybe proving it, in fact. So for proving these two triangles similar, you can see one angle is common over here, and in this triangle, this is 90 and this is 90 given. So you may do it, and over here I'm writing directly. That is, we can write that triangle ABQ is similar to A corresponds to A, B corresponds to C, and Q corresponds to R, right? I'm doing it directly. In the exam, you have to write down these two angles are equal for each 90 and this is common. So this is something that you have to do. Now, if two triangles are similar, we can write their sides as proportional. So here the proportionality first two letter, that is AB, will corresponds to side AC, will be equal to BQ. BQ corresponds to CR. Now I'm not taking the third side, reason being the third side has no application over here in proving this. So if I plug in the value of what we know here, this is AB over AC. I can replace BQ from the figure. If you see, BQ is what? Y. And from the figure, CR is what? Z. So let's mark it equation 1. Once we have proved these two triangles similar, next we are going to prove the other two triangle. And the other two triangles, as we have can see from here, that we will be taking one triangle as this and the other as this triangle. So here too also we can prove similar by AA similarity condition. The condition is AA similarity. Now check here. If I take the triangle, let's say if I take the first triangle as say CBQ is similar to the other triangle. Corresponds to C as it is common. B corresponds to A and Q corresponds to P. So if I use the proportionality over here, I can see that it is CB corresponds to what? CA, or AC is all same, and BQ corresponds to AP. So I mark it equation 2. Now here too I'll plug in the value. I can see that CB we don't know, AC we don't know, BQ from the figure it is Y, and AP from the figure is X. So say I mark this equation 2, not this one. Now what you can observe here, that we have same from equation 1 and 2. Check here. We have AB over AC on the left hand side. Right. We'll be adding these two equations, right? So not equating, adding 1 and 2. So adding equation 1 and 2. So I'll show it. AB, the LHS will be added with LHS. BC or CB is all same, is equal to, on the RHS is what? Y over X. And the second equation, sorry, this is Y over Z, not X. Y over Z from this plus Y over X. Now we have the same denominator here, so it will result to give you AB plus BC. And this, if I take Y common, why I'm taking Y common? Because I can see we need 1 over X. Right, if I take Y common, so this comes out to be 1 over Z plus 1 over X. And now from the figure, you have to see what is AB plus BC as. If you look into the figure, you'll be able to figure out what is AB plus BC. AB is this, AB is this, and BC is this. So when they are added, you'll get what? AC. So that means I'll replace this with AC. So this will give you what? AC over AC. And on the right hand side, we have Y that multiplied by 1 over Z plus 1 over X. Check here, these two get cancelled to give you 1. And if I transpose Y to the left hand side, if I transpose this y to the left hand side, it will become what? 1 over y, right? It should become 1 over y, right, on transposing. And that's what we need to prove. We can see this is what we needed to prove. 1 over y is equal to 1 over x plus 1 over z.